everyone. This is the fourth lecture on of module 1. Today what we are going to see is what we have been doing is we have been reviewing some of the concepts in structural analysis 1. Today we will see what is static and kinematic admissibility, and then we introduce what is compatibility. Okay. You see, say the term admissibility, what is the meaning of term admissibility? Admissibility is, we say something is admissible, means something is valid or something which is acceptable, right? Then we say that this is admissible. Now, before coming into the point what the admissibility means in structural mechanics, let us try to bring one analogy so that you can we can put the definition of admissibility in a proper perspective. Okay. For instance, take one example. Suppose you want to buy one shoe, right? You want to buy one, say, running shoe, or to be specific, you want to buy a running shoe which is blue color. Now, this is your condition, suppose. Now, what you do is you go to any footwear store. Now, when you enter a store, then you have a variety of collections of different kinds of shoes, slippers, sneakers, different kinds of footwear. Now, what is your job? Your job starts from there is you have to find out a shoe which you want, or rather you have to find out a shoe which is consistent with your requirement. Okay. Now, what you do there, first, for instance, when you go to a any footwear store, you get, this is just for a representative figures. You can have, say, thousands, hundreds of collections, but it is just to make the point. I took some variety. Now, suppose this is the entire collection you have. So, this is the entire space. Now, your job is to, from the entire space, select the one which satisfies your requirement. And what are your requirements? Now, first requirement is it should be a shoe. We don't want any slipper, you don't want chappals, you want a shoe. So, from this entire collection, so you take only those which are shoes. So, these are all shoes. Right? So, these out of all 8, all 7, these 4 satisfy this condition. Now, then your next requirement is it should be a running shoe. Now, your next requirement is a running shoe. Now, out of these 4, all are not running shoe. Now, only these 2 are running shoe. So, these 2 satisfy your this condition as well as this condition. Now, then your requirement is furthermore. You are not satisfied with only the running shoe, you want a shoe whose color is blue. So, out of these 2, only if the next condition is, then these satisfy this condition. Now, then we say this is admissible with respect to your requirement. Okay. This is admissible because this is the shoe, this is the running shoe, and this is the color of the shoe is blue. So, it satisfies all the condition, all the requirement that you have. So, now if we say the second one, if we say this collection, these two are admissible with respect to this condition and this condition, but this is not admissible when we put another condition that the color has to be blue. Similarly, these 4 conditions, this one is admissible only with respect to this condition, only with respect to this condition. But when these are not admissible when we put this as condition and this as condition, right. So, when we say the admissibility, then it is not an absolute word. Admissibility always comes with a condition with respect to which condition something is admissible, right. Now, in this example, with respect to all these condition, this one is admissible. Now, you see, when we what is the ultimate objective of structural analysis? Structural analysis ultimate objective is to find out a solution. Find out a solution means, say for instance, if you want to find out the deflection of a structure, internal forces, support reactions of the structure, what are these internal forces, support reactions, or say deflection? They are the solution of mathematical model representing the structure, right? If you remember, we discussed what are the steps we follow in structural analysis. So these bending moment, shear force, all these internal forces, support reaction, deflection, they are the solution of some mathematical model. Right. Now, when you solve an equation, essentially what we do, we search for a solution. It is very similar to when you go to a footwear shop and search for a shoe. Now, when you search for a shoe, you try to identify the one which satisfies your requirement. Similarly, when we search for a solution, we have to find out the solution which satisfies our requirement or requirement of a structure, right. Now, what are the requirements a structure can have? Now, as I said, whenever we talk about admissibility, it is always associated with a condition, some conditions. Admissibility has to be with respect to certain condition. In structure analysis, we have such two conditions. One is static admissibility and one is kinematic admissibility. Static admissibility, a condition which is with respect to the equilibrium of this entire system, and the kinematic admissibility is something which is related to the compatibility of the entire system. Now, in order to demonstrate that, let us take one example here. This is we already now know what is indeterminate and determinate structure. So, this is a statically indeterminate structure, right? Why it is statically indeterminate structure? Because if we draw the free body diagram of the structure, then we have two forces here. We have two forces here. These are hinge. These are two forces, right? Two forces, and then we have this is the externally applied load like this. Now, suppose this is AY, the vertical reaction, and this is BY, the vertical reaction at B, and this is BY, the vertical reaction, BX, the horizontal reaction at B, and this is AX, the horizontal reaction at A. So, this point is A and this point is B. Right. Now, if we and then this is Q and this entire length is L, right. Now, you see, if we write the free body, if we write the equilibrium equation, the equilibrium equation is summation of Fx is equal to 0. Now, summation of Fx is equal to 0 means what? This gives me that Ax plus Bx is equal to 0, right, or we can say that Ax is equal to minus Bx, right. This is the condition. This is how Ax and Bx are related. Now, if we take another condition, that summation of Fy is equal to 0, summation of Fy is equal to 0, this gives us Ay plus By is equal to Q into L, right, total external load. Now, we have summation of M, say at M A is equal to 0. If you can apply this. If we take summation of M A is equal to 0, this gives us By is equal to Q L by 2, right. If By is equal to Q L by 2, if I substitute this, then we have Ay is equal to Q L by 2. So, we have determined what is now how many unknowns we have here? We have one unknown Ax, Ay, Bx, By, total 4 unknown, and out of these 4 unknowns we have determined what is By and we have determined what is Bx, and we have used already all equilibrium equations, and these still we need to find out Ax and By. Now, we have one equation that Ax plus By is equal to 0, but still we are short with another equation. and that is obvious because here the static indeterminacy of the problem is 1. So, we need one more additional equation. Now, you see here, if I consider a force system which now A y and B y is q L by 2, which is we have already obtained, right. So, forget about that, but A x and B x satisfy this equation. So, as long as A x and B x satisfy this equation, then we say this entire force is means A y is equal to q L by 2, B y is equal to q L by 2, and A x and B y B x such that A x is equal to minus B x. If it happens for some A x and B x, then we say these forces, these reactions are admissible. Admissible, it is called statically admissible. Why it is statically admissible? Because for instance, if I have say A y is equal to q L by 2, B y is equal to q A L by 2, and if I say that A x is equal to say 5 and B x is equal to minus 5. Suppose I have a solution like this, okay. Then all this A x is equal to 5, B x is equal to minus 5, A y is equal to q L by 2, B y is equal to q L by 2, all these 4 forces are statically admissible, because as far as equilibrium equations are concerned, all these forces satisfy the equilibrium equation. Similarly, if I do not have A x is equal to 5, B x is equal to 5, if I take A x is equal to 15 and B x is equal to 15 minus 15, then also x this and this, they satisfy the equilibrium, right. So, even that also statically admissible. So, statically admissible or the static admissibility here is the all these forces and internal forces and support reactions, they satisfy the equilibrium, right. If they satisfy the equilibrium, then we say that it is statically admissible. Now, right, static admissibility is not the only thing that we want our solution to satisfy. For instance, in the previous example, the analogy that we brought, shoe having, just because it is shoe, something is shoe, is not enough to satisfy our requirement. In addition to that, the shoe has to be running shoe. In addition to that, the shoe has to be of blue color. Similarly, here only satisfying the static admissibility, only satisfying the equilibrium condition. Suppose you have a set of solution which satisfy the equilibrium condition, you have set of support reactions, internal forces which satisfy the equilibrium conditions. Yes, they satisfy the equilibrium conditions, but only satisfying the equilibrium condition will not qualify something to be a solution of this system. We need something else, some other requirement also need to be satisfied, and that requirement is kinematic admissibility. What is kinematic admissibility? See, kinematic admissibility, now when you any structure, if you take, the structure has some support condition. Now, the structure, if you apply a load, the structure undergoes deformation. Now, the deformation of the structure should be such that it is kinematically admissible, means the deformation of the structure should be such that it satisfies all the boundary conditions and the continuity requirement in the deflection. For instance, take, so this case is, this one is, in this case it is statically, it is this problem is for any value of A x minus B x, this is statically admissible, because equilibrium is satisfied. Always we have A y is equal to B y, we have already determined q L by 2. So, for any value of A x is equal to minus B x, this is equilibrium is satisfied, but any value may not be kinematically admissible. Let us see with the same example what does this mean. Now, as I said, for any value of h, if we take any value of h, then this is statically admissible. Now, let us see what happens for different, what happens to the deformation of the structure for different values of h. you see we have just changed H with H and these are the deform shape for different values of H. Now, what is the kinematic condition we have here? Now, this support and this support, this is a roller support and no, this is a, and our previous, if you go previous page, then our support condition was a point A and point B, they have their hinge support. So, they cannot, there will be no translation takes place at point A and B. Now, let us see if we change value H, when H is equal to minus 2.5 kilonewton, the deformed shape is like this. When H is equal to 3 kilonewton, the deformed shape is like this. Similarly, when H is equal to 1 kilonewton, deformed shape is like this. For minus 1 kilonewton, deformed shape is like this. Now, you see for all H, minus 2.5, 3, 1 kilonewton, 5, minus 5 kilonewton, minus 3 kilonewton, they all satisfy the equilibrium condition, because all this for H, X is equal to H and Bx is equal to minus H. So, all these H satisfy the equilibrium condition, but the deformation that we obtain for different H, just by looking at the deformation we can easily say that these deformations, all deformations are not consistent with the boundary conditions given here, and the boundary condition says that at point A and B there will be no translation, whereas for this H, for these all this H, we have translation at the boundary. So, among all these H, and we have an infinite set like this, we have infinite choices of H, we have infinite such deformation. So, among all these H, the H which satisfy the kinematic condition, the boundary condition will be our solution. So, in this case the solution will be this one, not this, not this, not this, not this. Okay. So, when your deformation satisfies this condition, this boundary condition and the continuity requirement, then we say that this deformation is kinematically admissible. And when we search a solution, search for a solution of a system, that solution should be such that we can have kinematic and static admissibility both. So, the solution should be statically admissible as well as kinematically admissible. This is a very important point, because you see in the third week you are going to have review of matrix theory, and there you will be studying rank of matrix, the requirement for having a unique solution for a system. And then when we actually analyze a structure using matrix method, then we will see those matrices will have certain properties, and then we need to do something. That's something, let us not bother right now. We have to do something so that the uniqueness in the solution can be ensured. But in this case the uniqueness is ensured. When we say the solution is unique, means it satisfies the both static and kinematic admissibility. Okay. Now, great. So, once we understand what is static and kinematic admissibility, so among all these among all these possible solutions, not the possible solution, among all these solutions which satisfy static indeterminacy, we need to enforce one more condition so that kinematic admissibility can also be satisfied. So, we need to have a unique solution other than the static equilibrium condition. We need additional conditions. We need additional condition, the way we had additional condition when we went to a footwear store to buy a running shoe. Similarly, here also we have to have an additional condition. And what is that additional condition? That additional condition is compatibility condition, right? Now, you see, so what we have discussed is, we have discussed what is static equilibrium, and then static equilibrium for many structures, static equilibrium alone cannot not sufficient to find out the solution to solve the entire structure, and those structures are called indeterminate structure. And then we saw what is static and kinematic admissibility. Essentially, our objective is to find a solution, to search for a solution, and the solution will be such that it satisfies the static and kinematic admissibility both. Static admissibility tells you how the equilibrium is maintained in the system, and the kinematic admissibility tells you how the compatibility maintains in the system. Now, structural analysis is based on its structural analysis has three important pillars. One is equilibrium. So, we have to have equilibrium satisfied, and then next is compatibility, means the boundary conditions and the continuity in the displacement, they both satisfy. So, this gives us static admissibility, this gives us kinematic admissibility. Now, we have one more important pillar which connects these two requirements, which connects the requirement. You see, the equilibrium is how the forces are in the system, and compatibility is how the displacements are in the system. And now, the middle pillar, the another pillar which combine these two, how the forces, the equilibrium and compatibility combine, the third pillar, which is called constitutive relation, means it tells you how the force, this equilibrium is something related to force, compatibility is something related to displacement, and then constitutive relation, the another pillar, tells you how these two important parameters, the force and the displacements, are related to each other, and that is called compatibility conditions. That is called constitutive relation. So, what we do in the next class is we'll revisit the compatibility condition. So, what is constitutive? We'll revisit the constitutive relation, not the compatibility. So, constitutive relation, there we come across two terms, one is stiffness and flexibility, which are very important because they are the building blocks. The stiffness and the flexibility are the building blocks of matrix method of structural analysis. You already have an idea about stiffness and flexibility. Next class we will just briefly review what is the concept, as a concept what is stiffness and flexibility. Okay, we will stop here today. See you in the next class. Thank you.